Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, we're going to attempt to define what a logarithm is. Okay, so I suppose what we really need is what is a logarithm? A logarithm. Okay, from a mathematical perspective, what is a logarithm? Okay, and maybe for me to try to, I suppose, let's say, to progress this particular idea, what I want to have a look at is I just want to have a look at a series of let's say, powers or exponents, okay, and what they actually are in numerical form. So let's say, for example, let's consider all the following numbers. Okay, so let's consider, let's say, for example, let's consider 10 squared. What's 10 squared equal to? Well, it's equal to 10 times 10. It's simply equal to 100. Okay. Let's consider another one. What's 10 cubed equal to? Well, 10 cubed is equal to 10 times 10 times 10, which is equal to 1,000. Okay. So what I have is I have some number we call the base, and I have some power or exponent. Yeah. So the base in this case is 10. The exponent is 2. Okay, so the base raised to the exponent gives us a specific value. Okay, so 10 to the 2 gives us 100. 10 to the power 3 gives us 1,000. And we know that. We've seen that so many times. Let's consider different bases and different exponents. So let's say we have 2 to the power of 4. Well, what's 2 to the power of 4? It's 2 times 2 times 2 times 2, which is equal to 16. Okay. What about 2 to the power of 10? Well, 2 to the power of 10 is equal to, we could use our calculator for this. Okay. Let me move over here so it's not as shady. So I want 2, second function, the power to the 10. Oh, oops, got square root there. So 2, second function, the power, 2 to the power of 10, whoops, is simply equal to, can you see that there? Yeah, it's simply equal to, it's equal to 1,024. So that's 1,024. Okay. What else could we do? We could say, let's say 5 to the power of 4. 5 to the power of 4. What's that equal to? Let's say 5 raised to the power of 4 is equal to 625. Okay, 625. The main thing here is this, is that in all of these cases, okay, we have a base number raised to a particular power. Okay. In this case, the base is 10, the power is 2. In this case, the base is 10, the power is 3. In this case, the base is 2, the power is 4. In this case, the base is 2, the power is 10. In this case, the base number is 5, and the power is 4. Actually, we should stop calling them powers and we should call them exponents. So we have the base is 10, the exponent is 2. The base is 10, the exponent is 3. The base is 2, the exponent is 4. The base is 2, the exponent is 10. The base is 5, the exponent is 4. And when we evaluate them, we get specific values. Okay. So let's actually just change these. Let's ask a different type of question. Okay. Let's change these. Let's ask the following question. Ask the following. Question. Okay. Let's say question. Okay. What should the power be? What should the exponent be? What should y be in order to get 100? Okay. What should y be? Okay, in order to get 1,000. Okay, if the base is 2, what should y be in order to get 16? If the base is 2, what should y be in order to get 1,024? If the base is 5, what should y be to get 625? Okay. Now, the important thing here is this, is that the question that we're asking is, what should I raise some base to? What power should I raise some base to in order to achieve a specific value? Okay. Now, we know that in this case here, that we should raise the base 10 should be raised to the power of 2 to get 100. And that's effectively all what a logarithm is. A logarithm is an exponent. So a logarithm is the exponent. It's the power that you need to raise a base to in order to achieve a specific value. So in this case here, the y that I'm looking for is, okay, I'm looking for y. What y, when we raise 10 to the power of it, gives us 100. So it's the y that's associated with 10 and 100. It's the y that's associated with 10 and 1,000. It's the y that's associated with 2 and 16. It's the y that's associated with 2 and 1,024. It's the y that's associated with 5 and 625. It's the y that's associated with a base and some number. It's a y that's associated with a base and some number, and so on and so forth, you can see. So actually, effectively, all a logarithm is this exponent. Okay. Now, what we usually say is this: is that y, in this case, y is the value, okay, of 100. It's the log of 100 to the base 10. That's what we define y to be. So y is actually equal to the log of 100 to the base 10. So if you have to calculate the log of 100 to the base 10, all it's asking you is what value should you raise 10 to in order to achieve 100. So you can see the way the base and the value are coupled together in the log, and the log is the actual value. In this case, it would be 2. Okay. In this case here, we're saying y is equal to the log of 1000 to the base 10. Okay. In this case here, we're saying that y would be equal to the log of 16 to the base 2. In this case, we're saying that y would be equal to the log of 1024 to the base 2. And in this case, the y, by definition, is the log of 625 to the base 5. Now, these have specific values, okay? This is what the y represents. It's what value, what power should we raise 10 to in order to achieve 100, which is exactly what we have here. And what we call this exponent, okay, this actual value, this y, we say y is the actual exponent, okay, the exponent y is, we give it another name, we call it is the value, the log 100 to the base 10. And in this case, the y is log 1000 to the base 10. It's the power that we raise 10 to achieve 1000, and so on and so forth. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at National College of Ireland. And I hope that this video was in some way intuitive, dealing with logarithms and what a logarithm actually is. Okay, so once again, thank you for watching, and I hope that this was helpful. Okay, bye bye.